All right, so this is going to be part 2 of using laws of exponents. Okay, so this one says simplify this product. Okay, this is just a bunch of multiplication going on here. All right, and I'm going to go through this one in detail. Okay, and then maybe once we get a little more comfortable, we'll be able to skip some steps on these next two. Okay, so first things first, let's recall that multiplication is commutative. What do I mean by that? I mean that x times y is the same thing as y times x. Okay, x. All right, and x times y times z is the same thing as z times y times x. Okay, you can move stuff around in multiplication. All right, for example, 3 times 2 is 6, and 2 times 3 is 6. Okay, you can do the same thing with any amount of numbers for multiplication. You can just move them around. All right, so that's what we want to. That's how we want to approach this first problem. Okay, so let's do that. So what this really says here, what this statement here really says is 10 times x to the 5th times y to the 7th times 3 times x to the 5th times y to the 7th. Okay, so what I want to do here is I want to move them around so that each one is next to their corresponding, I guess, counterpart. Okay, so for example, I want to put the 10 and the 3 next to each other, the x's next to each other, and then the y's next to each other. Okay, well, thankfully multiplication is commutative, so I can do that just like this. 10, right? So I'm just going to rewrite this like this. 10 times 3 times x to the 5th times x to the 5th times y to the 7 times y to the 7. Okay, well, what's 10 times 3? Okay, so now you can just do the multiplication that it consists of. Okay, so what's 10 times 3? 10 times 3 is 30. X to the 5th times x to the 5th is going to be x to the 5 plus 5 because we have the same base here. So we're going to get times x to the 5 plus 5 because x to the 5th times x to the 5th is x to the 5 plus 5, which is going to be x to the 10, times y to the 7 times y to the 7. We have the same base, right? The same base here is y. Y to the 7 times y to the 7. All you have to do, since it's multiplication, is add the exponents. So we get y to the 14, and that's all you have to do. The problem is over. Okay, we've simplified it. Normally, simplify just means to reduce the amount of terms or reduce the numbers. Okay, 15. Let's look at this one. All right, 15 times 4. Let's go to the side and do that. 15 times 4. 5 times 4 is 20. Carry the 2. 4 times 1 is 4. Plus 2 is 6. So we get 60. X to the 6 times x to the 10. Well, x to the 6 times x to the 10 is just going to be x to the 6 plus 10, right? So we're just going to get x to the 16. Okay, so we're going to get x to the 16. And then y, we have that it's y to the 8 times y to the 20. Same base. The same base here is y. So we can... So since it's multiplication, we can add their exponents. So we're going to get y to the 8 plus 20, okay? And we'll get y to the 28. And that's our final answer. Okay? So guys, please be very careful, okay? 15 times 4 is 60. All right? X to the 6 times x to the 10 is x to the 16. Okay? Please do not write something like this. Okay, a lot of you guys get the urge to write something like this. All right, x to the 6th power times x to the 10th power is not x to the 60. Okay, you do not multiply these exponents. You just add them. Okay, so you just get 16. Okay, please be careful. All right, let's look at this one. We have 12 times 4. Let's go to the side and do that real quick. 12 times 4. 4 times 2 is 8. 4 times 1 is 4. So we get 48. Okay, that was these two. Okay, so now maybe we can look at maybe these next two down here. Maybe just soon, the more comfortable you are with this, the more you can just jump around and just multiply them. Okay, so now we have x to the 5th times x to the 7th. So x to the 5th times x to the 7th, which is going to be equal to x to the 5th, x to the 5 plus 7, which is just going to be x to the 12. Okay, so we get 48x to the 12, and then we can do the same thing with the y's. All right, let's do the same thing with the y's here. Okay, and then we'll get, let's see, we're going to get y to the 7th times y to the 9, which is going to be y to the 7 plus 9. 7 plus 9 is 16, so we'll just get y to the 16. And that's it. That's all you have to do, okay? These are test level problems, so if you feel comfortable doing this, you should be very comfortable on the test, okay? All right, let's go to this next slide. Okay, so here's a few examples, okay? And realize that we have negatives in the exponents, all right? Well, let's recall this one of our important laws of exponents. It's a very important law. It says that x to the negative a is equal to 1 over x to the positive a, okay? That's how you get rid of this negative exponent, okay? This is not a negative number. This is a positive number. It's 1 over x to the positive a, okay? Let's approach the rest of these examples using this law we have here, all right? So 7 to the negative 2 is going to be 1 over 7 to the positive 2, okay? Well, 7 to the positive 2, 7 squared, 1 over 7 squared is just 1 over 7 times 7. And 7 times 7 is 49, so we get 1 over 49. Okay, so just because we got 7 squared, make sure you multiply it, right? Because on the test, the only options they give you might just be the actual value that it's equal to, okay, using whole numbers, all right? Let's do the same thing with this 9 to the negative 2. We'll get 1 over 9 squared, which is going to be the same thing as 1 over 9 times 9. 9 times 9 is 81, so we get 1 over 81. Okay, same thing here. 5 to the negative 3 is the same thing as 1 over 5 to the positive 3. Okay, that's all you do. Okay, it's negative 3. You do the same thing. 1 over 5 cubed, which is going to be 1 over 5 times 5 times 5. 5 times 5 times 5 is really one you should know, okay? And it's 125. Okay, you can go ahead and check that if you'd like. This is one you should know. 4 to the negative 2 is going to be 1 over 4 squared, okay? 4 squared is 4 times 4, so we get 1 over 16. 4 times 4 is 16. 10 to the negative 2, okay, same thing. 1 over 10 squared. 10 squared is the same thing as 10 times 10, which is going to be 1 over 100. 10 times 10 is 100. Okay? 10 to the negative 5 is going to be 1 over 10 to the 5th. Okay, all you have to do here, there's a little nice trick for the tens when you raise the tens to a positive power. All you have to do is put down the 1, and whatever the exponent is, the positive exponent on the 10, so in this case it's a 5, all you have to do is put 5 zeros. 1, 2, 3, 4, 5. Okay? And you put your commas. Okay? Always start your commas going from right to left. Okay? So 1, 2, 3, comma. 1, 2, 3, comma. Okay? 10 to the negative 3 is going to be 1 over 10 cubed. Okay? Which is going to be 1 over, well, we can use a nice little tens trick. All you do is put a 1. What's the exponent is a 3. So all you do is put 3 zeros. 1, 2, 3. Okay? Those are your answers. 10 to the negative 6 is 1 over 10 to the positive 6, which is just going to be 1 over the number 1 followed by how many zeros? 6, because the exponent's a 6. So 1, 2, 3, 4, 5, 6, comma, comma, and there's your answers. Okay? And this is going to conclude the laws of exponents videos. All right. If you have any questions, feel free to ask me in the comments, and please subscribe and turn on your notifications so you so you're familiar with when I upload some more videos. All right, thanks guys.